Hey guys, welcome. Make sure you label the heading 4 video. It's very important that it's at the very top. Okay. There's actually no theorems for this chapter, which is awesome, but we do have the essential understanding. So let's go ahead and talk about that. It's right here. So please go ahead and write this down. So make sure you write this down. Very important. So hard to write on this sometimes. That says right, if you believe it or not. But make sure you write this down. It says, if you know two triangles are congruent, then you know every pair of their corresponding parts is also congruent. Okay? This is highly important. I can show any piece of a triangle. Remember, there's 6 parts to a triangle. In our special ways of proving triangles, we only need to use 3 things. So I can actually shortcut my way of proving triangles, and then I can basically, once I show the triangles are congruent, I can show any part of that triangle is congruent to its corresponding part. So we're going to take a look at what this looks like. But for ease, we actually call this CPCTC. So make sure you write that down. It stands for corresponding parts in congruent triangles are congruent. Kind of a mouthful. But again, corresponding parts in congruent triangles are congruent. So this is how we're going to go ahead and use it within a proof. So let's go ahead and look at our first proof right now. So the proof is called proving parts of triangles congruent. So we're going to go ahead and take a look at this example. So we have our picture over here. We want to show that KB, this segment here, and AC are congruent. Okay, well, I don't really know how I could show that, but I could show the two triangles congruent first and then use CPCTC to go ahead and do that. So let's go ahead and set that up. So we're going to go ahead and do a normal proof. Okay, so we're going to do our statement, and then our reason. Okay? Okay. So looking at the picture, I see I have 2 angles given to me already. I'm trying to think about which one I can use. I want to prove anything else I can prove. I see that they're sharing BC, so I know that's good. So it looks like I could do angle, angle, side. So I'm thinking angle, angle, side, and this is actually one of the ways I can prove a triangle, so we're going to actually go ahead and use this method for this triangle proof. So I'm going to prove the triangle is congruent first, and then I can show that that piece is correct. So I'm going to switch over to black. So statement 1, we're going to go with our given. So angle KBC is congruent to angle ACB, and we know that angle K is congruent to angle A. And this was all for the reason of given. They told us, they said, hey, look it, these are good. And so we're like, good. Okay. Off to the side, I always like to write down what we've already proved. Well, we proved an angle, and we proved an angle. Now I have to prove the side. So step 2, we're going to prove our side is good. So we got BC is congruent to BC. Okay, and we know that because of reflexive property. Kind of got that in the way, my bad. So now we have all 3 pieces. So there's the angle, angle, I'll put the side up here, my bad. But angle, angle, side. So we've check marked all of our pieces. We can go ahead and now make our final triangle proof. So we can go ahead and say, all right, step 3, we can say triangle, and now we got to be careful that we line up the triangle correctly. Okay, so it doesn't matter how we line up the first one, but I'm going to say CBK is congruent to triangle. Now we got to match it up. So what matches with C up here is going to be the B down here. Okay, and then so we're going to get triangle. Let's see. Let's do it the other way. K matches with A, and then C matches with B, which is kind of confusing, and then B matches with C. So there we go. There's our triangle. And the reason why was angle, side. Now I've proven the two triangles congruent. If we look back at that essential understanding, it's stated if I can prove two triangles congruent, then I can prove all their corresponding parts are congruent. So now I can actually get to my final statement and say, hey, look at, because of this, KB is going to be congruent to AC. And the way I know that is that corresponding parts in congruent triangles are congruent. And so that's kind of like our big takeaway. That's like the big thing that we want to talk about is this guy right here, CPCTC. So that is the kind of like magic thing. We prove the triangle congruent first, then I can prove any piece is congruent by using CPTC or CPCTC. It's a mouthful. All right, and then let's go ahead and look at our next problem here. Our last problem. Okay, so again, we're proving triangles, parts congruent. So this is kind of a cool little problem, so I'll go ahead and read it. It says, Thales, a Greek philosopher, is said to have developed a method to measure the distance to a ship at sea. So here's our ship at the sea. He created a compass by nailing two sticks together. Standing on top of a tower, he would hold one stick vertical and tilt the other until he could see the ship S along the line of the tilted stick. Okay, so he's up here somewhere. With this compass setting, he would find landmark L, so landmark L, on the shore, and along the line of the tilted stick, how far would the ship be from the shore? Okay, so we're given a couple pieces. We want to find how far is the ship from the shore, so we want to show that RS and RL are the same. Okay, so we can do this. So we're given a couple things. We know that on the tower, we're going to get right angles. So there's going to be right angles in here. We can go ahead and mark that. You don't have to write this down yet. The picture's going to change in a second, but we got right angles down here. And then we know that RTS, this angle here and this angle here are congruent because he used the stick to measure it, the tilted stick to measure that. Okay? Well, let's move a little bit forward, and we're going to actually turn this into a more straightforward proof. Okay? So I'm moving back over here. So here's our picture. Like I said, we want to go ahead and show that we have right angles, so we're going to go ahead and move on. Which congruency rule can we use? So we have some information. We have two pairs of angles. We might use angle, angle, side, or angle, side, angle. One of those two, we're not sure. We can guess and check. So let's see if we can determine if we can use angle, angle, side. So we got the angle up here, the angle here, the angle here, and the angle here, and then we have this side here that is congruent. Whoops, I'm still in the way. I keep getting in your way. To use angle, angle, side, you need information about RS and RL, or TS and TL, which unfortunately we wouldn't know how to measure. So we cannot use angle, angle, side, but we can probably use angle, side, angle. So let's go ahead and set up our proof. Again, I'm going to mark it real quick. At this point, this is what we should write down. I want the picture, I want the given, the proof, and the statement and reason. So make sure this is the part that's written down. Okay? So let's go ahead, and I'm going to use colors here. But here we have this angle here and this angle here are congruent. We have this angle here and this angle here. Oh, marker's kind of hard to write with. And then we have, let's see here, we have this side congruent to itself. Okay, so that's how we get angle, side, angle, angle, side, angle. So that's what we want to go ahead and prove. All right, so we have our proof pattern. What we want to do, we want to do angle, side, angle. And once we prove the triangle congruent, we can use CPTC to prove RS is congruent to RL, which thus means we know how far the ship is, since we know how far the tree, the landmark, is from the tower. Okay, because we couldn't measure this over the water, that'd be too difficult. So let's go ahead and move on. So we go ahead and move in and put our given statement. We know our angles up here are congruent, so that's good. We know that TR is congruent to TR, that's reflexive property. Again, I like to go ahead and write what we know. Look at, we just got an angle right there, we got a side right there, so we're styling. Moving on, okay, we have right angles. Okay, so right angles, they're going to take this in 2 steps, which is kind of cool. We first say we have right angles, but then we have to say they're actually congruent. Okay, so we actually have to say that they're congruent, which we actually did this piece a while ago. So all right angles are congruent, and look at, they even highlighted them for us, ASA. So we've proven this guy off. Now we have to go ahead and actually state the triangles are congruent by angle side angle postulate. So now we know the triangles are congruent, and the last step is we state RS and RL in fact are congruent. Corresponding parts of congruent triangles are congruent, and like I said, you guys can just write C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Same thing. Okay? Well, guys, hope you enjoyed the video. Peace. We out. That's all from us today.